Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about reliability analysis. Even before I proceed to demonstrate how to conduct reliability analysis using SPSS, may I request you to subscribe to my channel, also like and share my videos. Let me begin by asking 5 important questions. The first one, what exactly do we mean by reliability analysis? The second important question, what is Cronbach's alpha? The third important question, how can I calculate the Cronbach's alpha value? The fourth important question, how do I interpret the results of Cronbach's alpha? And the fifth important question is, how do we improve the Cronbach's alpha value? For each of these questions, we will have answers in today's video. Let me now explore the first question, what exactly is reliability analysis? And why do we calculate the reliability analysis? You can use reliability analysis to determine how the items in your questionnaire correlate with each other. This allows you to find the appropriate items for your scale. Reliability consists of stability, consistency, and equivalence. Let us now ask precisely what do we mean by reliability analysis. Reliability analysis is a statistical method which is used to assess the consistency, stability, and dependability of a measurement instrument or a system. This is worth repeating. Reliability analysis is a statistical method which is used to assess the consistency, stability, and dependability of a measurement instrument or a system. It helps to determine the extent to which a measurement or a system produces consistent and accurate results over time. In the context of measurement instruments such as questionnaires, reliability analysis evaluates the degree to which the instrument consistently measures what it is intended to measure. Let me repeat these words. In the context of measurement instruments such as questionnaires, reliability analysis evaluates the degree to which the instrument consistently measures what it is intended to measure. It assesses the extent to which the items or questions within the instrument yield consistent responses from participants or respondents. This is as far as reliability analysis is concerned. The second important question here, which I'd like to explore, is how do you calculate reliability analysis or reliability test value? The answer is very simple. We can use a simple measure which is called as Cronbach's alpha value to evaluate whether the questionnaire that you have designed is consistent or not. In simple language, Cronbach's alpha is a measure of internal consistency. Cronbach's alpha tests to see if multiple question Likert scale surveys are reliable or not. It will tell you if the test that you have designed is accurately measuring the variable of interest. Now, the second question that I'd like to ask is, how do we calculate the Cronbach's alpha value? As you can see here, there's a very simple formula which helps me calculate the Cronbach's alpha value. Cronbach's alpha value is equal to n multiplied by c divided by variance plus n minus 1 into c. It's worth repeating this point. Alpha value is equal to n multiplied by c divided by v plus n minus 1 into c. Now you may ask a question, what exactly is n, c, and v? N here stands for the number of items. Suppose in your scale, you have 10 different items. The value of n will be 10. The next important element here is C. What exactly is C? C stands for average inter-item covariance among the items. I repeat, C represents the average inter-item covariance among the items. Obviously, you can't calculate this manually. You need a software like SPSS or data tab to calculate the value of C. This is as far as the numerator is concerned. Let's now proceed to look at the denominator. You have V. What is V? V stands for the average variance. I've already explained what is N and C. I'll not repeat this once again. Now, how do we interpret this and what is the impact of each of these terms on the alpha value? This is very, very important for us to understand. There's a very simple thumb rule. As the numerator increases, the overall value of Cronbach's alpha also increases. On the other hand, if the numerator decreases, the value of Cronbach's alpha also decreases. What about the denominator? As the denominator increases, the overall value of alpha comes down, and as the denominator decreases, the overall value of alpha goes up. What does this mean? The Cronbach's alpha value increases when the number of items is increased. This is very important. When n increases, the value of alpha increases. Let us say you have 10 items in the first iteration. You may get a Cronbach's alpha value of 0.5. If you were to increase n from 10 to 15, you can expect a Cronbach's alpha value to also increase from 0.5 to 0.6. If you further add sensible and relevant items to the existing scale, you can expect your Cronbach's alpha value to shoot up further. This is why we say the Cronbach's alpha increases when the number of items is increased, and also when the inter-item correlation increases. This is a very important point. These are the two simple ways in which you can boost your Cronbach's alpha value. Increase the number of items. Number two, you can go ahead and increase the inter-item correlation, which further boosts up the Cronbach's alpha value. The second important point which I'd like to say here is as follows. The Cronbach's alpha value becomes smaller and smaller when the average inter-item correlation becomes smaller. I repeat, the Cronbach's alpha value becomes smaller when the average inter-item correlation becomes smaller. Have a look at the term average variance. If the average variance in the data shoots up, you can expect the Cronbach's alpha value to come down. On the other hand, if the average variance shrinks or it becomes lesser, I can expect the Cronbach's alpha value to go up as well. So this is how we can improve the Cronbach's alpha value. This is a point which I would like to repeat because many research scholars ask me what is the best way to improve the Cronbach's alpha value. As far as practical suggestions are concerned, I'll be showing you how you can boost the Cronbach's alpha value. As of now, you can remember two important points. By increasing the number of items and by increasing the inter-item correlation, you can boost your Cronbach's alpha value. Let's now proceed to look at the interpretation of Cronbach's alpha. As you can see here, I have a table here which talks about the interpretation. This represents a table using which we can interpret the alpha for dichotomous or Likert scale questions from George and Mallory. So there were two people, one is George and the second is Mallory. These two guys proposed in 2003 as to how you can interpret the Cronbach's alpha value. Suppose you run a reliability analysis using Cronbach's alpha, your answer can be any of these 6 cases. The first case is when you're obtaining a Cronbach's alpha value of above 0.9. I repeat, if you're obtaining a Cronbach's alpha value of above 0.9, congratulations to you. This means that there is internal consistency in your data, and this indicates excellent reliability. A value of 0.9 or above indicates excellent reliability. Let's look at the second case. In the second case, you may get a Cronbach's alpha value anywhere between 0.8 and 0.9, in which case it means your data, the scale, has good reliability. From excellent, now I'm saying we have good reliability. The third case is a case wherein your Cronbach's alpha value may lie anywhere between 0.7 and 0.8, in which case you can again pat yourself on the back and say we have acceptable reliability. Irrespective of whether it is case 1, case 2, or case 3, all of these are satisfactory results. Now, this is a dangerous situation when we fall into case number 4. Suppose you run a reliability analysis test and you get a Cronbach's alpha value between 0.6 and 0.7. It means your data has questionable reliability. This is a very, very unfortunate situation. It is better not to proceed with other analysis if your Cronbach's alpha value is between 0.6 and 0.7. You should be worried. You should be anxious about the questionnaire that you have designed. At the same time, in this video, I will suggest practical ways in which you can boost up your Cronbach's alpha if you belong to case number 4. What about case number 5? If your Cronbach's alpha is anywhere between 0.5 and 0.6, it straight away means that the questionnaire that you have in your hand is of very poor reliability. We cannot trust the reliability of such a questionnaire. Case number 6 is quite pathetic because in case you obtain a Cronbach's alpha value below 0.5, I repeat, below 0.5, it means that your questionnaire has unacceptable reality. So we should be worried if the Cronbach's alpha value is less than 0.7. Let me simplify all of this in a simple thumb rule. Your Cronbach's alpha value typically lies between 0 and 1. If your Cronbach's alpha value is bigger than 0.7, you're safe. I repeat, if your Cronbach's alpha value is bigger than 0.7, if it is greater than 0.7, you're safe. On the other hand, if your Cronbach's alpha value is less than 0.7, you should be worried, you should be anxious. This is the criteria proposed by George and Mallory in the year 2003. In this video, we will be looking at how to obtain the Cronbach's alpha value through SPSS. Also, we will be looking at practical steps as to how we can boost the Cronbach's alpha value. But before proceeding to SPSS, I'd like to show you the scale as well as the items that I'll be using in today's analysis. Let me now proceed to show you the Word document. This is the Likert scale data that I have. As you can see here, I'm trying to measure participants' attitude towards entertainment preference. What is your attitude towards entertainment preference? Do you watch TV, or do you like to swim? Do you play cricket? Do you participate in any of the social activities? This is what we are interested in measuring. As you know, ordinal data is the data where there is ranking or ordering amongst the observations of a variable. Typically, when we speak about a 5-point scale, we can classify such data as ordinal scale data. Suppose somebody were to ask you a question. Do you think all politicians are corrupt? And he gives you 5 questions. That is, strongly agree. He wants to know, do you agree with that statement that all politicians are corrupt? The second option that you have is agree. You don't strongly agree, but somewhere you agree that all politicians are corrupt. The third option that you have is neutral. The fourth is you disagree that all politicians are corrupt. The fifth option that you have is you strongly disagree that all politicians are corrupt. So this is a classic example of Likert scale data. The second example is, do you like coffee? Again, you may be presented with 5 different options: strongly agree, neutral, disagree, and strongly disagree. This again is a question which belongs to what we call as Likert scale data type, and we classify this as ordinal data. Here, I am asking a simple question wherein we are interested to know about the participants' way of entertainment preference. This is a very, very important idea. Please pay attention. Entertainment preference. This is what we call as a latent variable. A latent variable is a variable which cannot be directly measured. The word latent means something which is not obvious, something which is not apparent, something which is hidden. Suppose I were to ask you what is your age or your salary. You will tell me your age is 25 years and your salary is 1 lakh, which means salary, age, and other factors can be measured. But if I were to ask you, what about your satisfaction level, satisfaction, happiness, depression, all of these can be classified as latent variables. It's not very, very easy to measure your happiness. It's not easy to measure whether you're depressed, sad. The same way, it is not easy to measure your response or your sentiment towards entertainment preference. So this is what we call as a latent variable. This is the first thing that you need to keep in mind. We always have a latent variable. Now, to measure a latent variable, we ask Likert scale questions. So this is the second step. You have a latent variable, you can't directly measure it. So number 2, what you do is you ask Likert scale questions through which you can assess the latent variable. In this example, I have a scale. What is a scale? A scale consists of multiple questions which help me assess the value of the latent variable. So this entire table that you see consists of 21 variables. You can see here attitude 1. ATT 1 represents attitude 1, ATT 2 represents attitude 2, ATT 3 represents attitude 3. How many such variables do I have? When I scroll down, you can see I've got 21 attitudinal questions. Now comes a very, very important thing, which is called as item. Each of these variables is called as an item. I repeat, each of these variables is called as an item. A group of items collectively make up a scale, and a scale is used to calculate a Likert scale. My apologies. A scale is used to calculate a latent variable. Here I have got the first item, which is I enjoy going to the cinema. The second item that I have is I like a wide range of choice in the video shop. The third item that I have is my leisure activities are mainly out of home. So you have different questions, 21 such questions. Have a look at the column. There are 5 values. The first is strongly agree. So if you were to say strongly agree, it means that you strongly enjoy going, you strongly agree to the statement, I enjoy going to the cinema. The second option that you have is agree. The third option is neutral. The fourth option is disagree. And the fifth option that you have here is strongly disagree. The value 1 stands for strongly agree. 2 stands for agree, 3 for neutral, 4 for disagree, and 5 stands for strongly disagree. So this is the questionnaire which we have designed. What do we intend to do? We intend to know about the participants' way of entertainment preference. We have these 21 questions. We have asked, we have administered this questionnaire to the participants, and the results we have saved in SPSS. You can have a look at the first variable ID, then you have respondent's gender, and this is where you have the first question, that is attitude 1. The second question, which represents attitude 2, and the third question, which is attitude 3. Like this, I have just taken a sample of 10 questions for the purpose of video. I wanted to be very clear in my explanation so that I do not confuse my audience, and hence I have not taken all the 21 questions. In real time, when you are operationalizing this, you have to take all the 21 questions. When you look at the first person's response, the first person who is carrying an ID of 2, he is a male. He has given a rating of 3 for attitude 1. He is again given a rating of 3 for attitude 2. But have a look at attitude 3. He has given a rating of 1. Now, what does 2, 3, 1 mean? In SPSS, when you click on this particular option, which is called as value labels, SPSS displays the labels for each of these 5 numbers. You can see here, neutral, the second attitude is again being recorded as neutral, and the first person has said he strongly disagrees. Repeat, he strongly disagrees for the statement number 3. What is statement number 3? My leisure activities are mainly out of home. So the first person has said he strongly disagrees. With this background, let's now proceed to look at variable view. This is the variable view. You can have a look at the attitudinal questions here. The explanation is given under the labels. When I scroll further to the right side, in the value section, when you click on any of the cells, SPSS gives you the value and the corresponding explanation. 1, 2, 3, 4, and 5. 1 for strongly disagree, 2 for disagree, 3 for neutral, 4 for agree, and 5 for strongly agree. Let me scroll further to the right side. You can have a look at the measurement type. SPSS has recognized this as an ordinal data type. Have a look at the icon here. You have different bars here. The tallest bar here is the red color bar. You have a green color bar, which is slightly shorter than the red color bar. And finally, you have a very short blue color bar, indicating that there is hierarchy or ranking amongst the observations of a ordinal variable. So this is as far as the data is concerned. Now, let us try to check whether there is reliability in this questionnaire. I repeat, do we have a reliability in this questionnaire? How do we do this? The answer is Cronbach's alpha value. Now, I'm going to go to the Analyze menu bar. Once you go to the Analyze menu bar, SPSS gives you different options. We have to go to the option Scale. Under the Scale section, you have 4 options. You can go ahead and select the very first option, namely Reliability Analysis. Let me hit the Reliability Analysis option. You can see here, this opens up a new dialog box, which is called as the Reliability Analysis dialog box. Be careful when you're selecting the questions. You don't need to select ID and respondent's gender. You have to select the 10 questions that are present in SPSS. Select all of these things using the control button in your keyboard, and you can move this into the item section. Make sure that you have selected the alpha value. This is the Cronbach's alpha value that will be produced under the model section. In case you're interested, please feel free to click on the drop-down menu. SPSS displays 5 options under the model. First is alpha or Cronbach's alpha. The second option is split half. The third option here is what is called as Gutmann statistic. Then you have parallel, and the last of the options is strict parallel. I will go with alpha. Once you have selected alpha, you can go ahead and hit the OK button. What you're seeing now is the output window of SPSS. There are 2 very small tables. The first one is called as Case Processing Summary. There are 328 valid cases. Excluded will be 0. So overall, you have 328 sample size in this data. This is not of much importance, so I will move on to reliability statistics. This is very, very important, and I'd like to draw your attention to the first column here, which is Cronbach's alpha value. The Cronbach's alpha value is 0.068. The number of items is 10. Since the Cronbach's alpha value is 0.068, what do I do? If you're not very familiar with SPSS, SPSS is very, very user-friendly. You can double-click on the Cronbach's alpha, right-click, and you can make use of this user-friendly option, which is called What is this? Let me select the option What is this? SPSS displays the explanation for Cronbach's alpha. It says Cronbach's alpha is a measure of reliability that is a lower bound for the true reliability of the survey. Further, it says the computation of Cronbach's alpha is based on the number of items on the survey and the ratio of average inter-item covariance to the average item variance. So this is the way in which you can refresh or quickly pull out the explanation for Cronbach's alpha. Now, most of you might be very, very new to reliability analysis, and therefore you may be wondering, how do I interpret 0.068? Let me open up the Excel table. You can see here 0.06. It is way below 0.5. So in my case, the Cronbach's alpha value is so low that it is below 0.5, and therefore it means that we have unacceptable reliability, which means the 10 questions are not doing a good job of assessing the entertainment preference from the participants. There is nothing to panic. We can make an attempt to boost the Cronbach's alpha value. How do we do this? Let's go back to SPSS. This is SPSS. Let me click on value labels. Now, there are multiple ways in which you can improve the Cronbach's alpha value. I'm going to show you a very simple trick using which you can boost the Cronbach's alpha value. Let me go ahead and select Analyze menu bar. Here, I'll go to Scale. You're already familiar with the navigation of reliability analysis. Here, I will be selecting reliability analysis. I'm not going to disturb any of these 10 questions. Let these be as it is. At the right-hand side top corner, you have a box which says statistics. Let me open up this box. Here, you have different options: reliability analysis, statistics. There are multiple options. However, I'd like to draw your attention to a very, very important life-saving option, which is descriptives for scale if the item is deleted. This is a very, very important option. You can check this box which says scale if item is deleted. With this selection, let me go ahead with the continue option. And now I'm going to perform a reliability analysis once again. You can see here, this is the second iteration of the reliability analysis. My Cronbach's alpha value is 0.068. Question is, how am I going to improve this? This table is very important. This is a very powerful table, and this will guide me as to how I can boost my Cronbach's alpha value. This table is called as item total statistics table. I repeat, it is called as item total statistics table. There are 5 important columns. The first column would be the variable names. The second column would be scale mean if item is deleted. What does this mean? To understand this table, begin with a simple question. What if? What if I were to delete a particular item? If I were to delete the first item, I like a wide range of choice in the video shop. The mean value would be 27.93. That's what it means. Scale mean if the item were to be deleted. Similarly, what happens if the second item is deleted? The mean value would go up to 28. What happens if the third item is deleted? The mean would be 28.77. Like this, SPSS prints what would happen to the scale if the variance item is, what would happen to the variance if the item is deleted. The third column is what is the corrected item total correlation. We don't have to worry about any of these 3 columns. What we need to worry about is the last column. This is the most important column in the analysis. This column is what happens to the Cronbach's alpha value if a particular item is deleted. I repeat, what happens to the Cronbach's alpha value if the item is deleted? You can see here, this is the impact on the Cronbach's alpha value if the first item would be deleted. The Cronbach's alpha value would be reduced to minus 0.315. I don't want to reduce my Cronbach's alpha value. I want to increase my Cronbach's alpha value. At this point, let me go back to the reliability statistics that I have. The current value of Cronbach's alpha value is 0.068. I want to improve it and push this above 0.7. Therefore, let me go back to the item total statistics table. You can have a look at all of these values and identify the maximum value. I repeat, in the last column, please identify the maximum value. The maximum value that I can see here is 0.433, which is for the third item, which means if you were to kick out the third variable, namely my leisure activities are mainly out of home, the Cronbach's alpha value would shoot up to 0.433. So this is how you can boost your Cronbach's alpha value. Let me reopen the reliability analysis dialog box. You can see here the third variable is the problematic variable. My leisure activities are mainly out of home. Let me kick this variable out. Let me hit the OK button. You can see here the new Cronbach's alpha value after removing the third variable is 0.433. Is it good? Let's look at what George and Mallory criteria says. 0.4. I'm still in case number 6, which is unacceptable reliability. What does this mean? My reliability analysis value has improved. However, it is not satisfactory. So I'm going to go back to my data set, reopen the dialog box for reliability analysis, and hit the OK button. You can see here 0.433. I'd like to boost this further. Again, we are generating the item total statistics table. Have a look at the last column, Cronbach's alpha, if the item is deleted. The maximum number is what I am supposed to see. The second one looks interesting. It is 0.647. The last item also looks very interesting because it is 0.630. Between the two of them, the second value is higher, which is 0.647, which means I have to now kick out the variable I enjoy going to the cinema. I repeat, I enjoy going to the cinema. This seems to be the problematic variable. If I were to kick out the second variable, my Cronbach's alpha value will jump to 0.647. Remember, my current value is 0.43. I'd like to improve it to 0.647. Let me reopen the dialog box, reliability analysis. The second variable here would be I enjoy going to the cinema. This is the second variable. Let me remove this variable from the list of variables and perform reliability analysis once again. You can have a look at the new reliability statistics value. What is the value? The value that I'm now getting is 0.648. Let me open up George and Mallory's criteria. I've got 0.6 something. While my situation has improved, but again, it says poor reliability. This is not satisfactory. Is there a way in which I can further improve the reliability analysis value? I'll have to look at the item total statistics table. Have a look at the last column, Cronbach's alpha, if a particular item is deleted. Out of all the numbers in the last column, the biggest impact on Cronbach's alpha will be made if I were to kick out the variable satellite dishes are a blot on the environment. This is a pretty strong statement. Satellite dishes are a blot on the environment. You can have a look at what will happen to the Cronbach's alpha value. If you were to kick out the last variable, the Cronbach's alpha value will jump to 0.798. Currently, we have a value of 0.64, which is not satisfactory. I'd like to kick out the last variable. By doing this, we will be able to boost up the Cronbach's alpha value. Let me quickly go to the dialog box, reopen reliability analysis. The last variable here that you see is satellite dishes are a blot on the environment. Let me remove this variable and hit the OK button. You can now see what is the new reliability statistics value. Under reliability statistics, you can see the Cronbach's alpha value is 0.79. I repeat, the Cronbach's alpha value is 0.79. In the table, when we say 0.79, this falls in the third criteria, which is acceptable reliability. So from poor reliability, straight away, we are obtaining a Cronbach's alpha value, which is of acceptable reliability. Which means what? Now that I have removed 3 questions, I'm left with only 7 questions. These 7 questions are doing a satisfactory job of evaluating the entertainment preference of the participants. If you want to further improve, you can look at the last column, 0.829. This is against the second question. I would rather watch TV than go out for the video. Now, this idea of removing those variables which have the biggest impact of Cronbach's alpha is good up to a point. But as you go on removing variables, the number of items will come down. So we have to watch out for the number of items as well. We need a happy balance between the two. So in this video, we have seen what exactly is a reliability analysis. We've seen what is Cronbach's alpha. We've also seen how to calculate the Cronbach's alpha value. What are the different terms which are involved in evaluating the value of alpha? Remember this golden rule. How do we improve the Cronbach's alpha? Cronbach's alpha increases when the number of items is increased and when the inter-item correlation increases. So these are the 2 control points that you have. If you want to improve Cronbach's alpha, you have to increase the number of items, relevant items, and when the inter-item correlation increases. The downside here is the Cronbach's alpha value becomes smaller when the average inter-item correlation becomes smaller. And this is the George and Mallory's criteria to interpret the value of Cronbach's alpha. I hope you have enjoyed this particular video. In this video, I have summarized the answers for 5 important questions. What is reliability analysis? What is Cronbach's alpha value? How can I calculate it? How do I interpret the results? And the 5th question is, how do I improve the Cronbach's alpha value in case it is not meeting the threshold value? Thank you very much for watching this particular video. Have a great day ahead. Do remember to subscribe to my channel, also like and share my videos.